Assalamualaikum, saya Amira Faizira binti Wan Amru, Bonaventure. Nombor matrik saya ialah 051617 dan saya mengambil jurusan Ijazah Sarjana Muda, Sains Komputer Pembangunan Peristian. Hari ini saya akan membentangkan report yang telah saya buat dan juga groupmate saya, iaitu phishing website dataset. Secara umumnya, phishing website adalah salah satu semantic attack yang hanya target kepada user dan bukan kepada komputer yang digunakan oleh user. Phishing ni adalah salah satu jenayah internet yang sama dengan hacking. Penjenayah phishing ni dinamakan phisher dan phisher ni dia akan membina satu laman web, satu replika laman web di mana replika tersebut adalah hampir sama ataupun 100% sama dengan laman web asli. Replika tersebut dibina untuk mengelirukan user yang dah masuk dalam replika laman web tu. Dengan menggunakan replika tersebut, phisher akan dapat personal information dan juga financial information user tersebut. Selalunya, phisher akan bagi satu link di mana link tu dihantar melalui email ataupun instant message, dan apabila user tekan link tu, dia akan auto ke replika laman web yang tiruan tu lah. Ada dua jenis algoritma yang digunakan untuk meramalkan laman web phishing. Yang pertama ialah associative algorithm dan juga yang kedua classification algorithm. Melalui algoritma ini, ia akan mendapat ciri-ciri laman web phishing dan juga bagaimana laman web phishing ni relate with each other. Terdapat dua objektif dalam projek kami. Pertama ialah develop data mining algorithm untuk meramalkan phishing websites. Kami akan membandingkan tiga jenis algoritma. Yang pertama, multi-layer perceptron (MLP). Yang kedua ialah J48 decision tree dan juga yang ketiga ialah naive Bayes algorithm. Kami akan membandingkan performance antara ketiga-tiga algoritma ini. Yang kedua ialah meramalkan jenis-jenis laman web yang di mana dia mempunyai ciri-ciri yang sama dengan classification data mining tersebut. Dan melalui classification data mining tu, dia akan mendapat ramalan phishing websites. Seterusnya, data selection. Dataset daripada phishing website ni adalah daripada Fish Tank Archive, Miller Smiles Archive dan juga Google Searching Operators. Dataset ni dia mempunyai 2456 instances dan instances ni mempunyai 31 attributes. Data-data yang diambil akan diubah dalam satu form di mana form tu dia akan diterima oleh data mining software. Dan menerusi data mining software tu, dia akan dibahagi kepada dua set, iaitu training dataset. Classification ni adalah teknik yang digunakan untuk discover classes of unknown data. Untuk mengklasifikasikan data-data phishing website ni, dia akan diambil daripada data yang mempunyai accuracy dan juga precision yang paling tinggi. Dan algoritma yang digunakan untuk train the dataset ialah multi-layer perceptron, J48 decision tree dan juga naive Bayes algorithm.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Tina Safia binti Umar Ruslan, nombor matrik 051705. Hari ini saya akan bercakap mengenai algoritma yang digunakan dalam phishing website dataset. Dalam projek ini, kami menggunakan 3 algoritma di mana multi-layer perceptron, naive Bayes dan juga decision tree. Okay, multi-layer perceptron is a feed-forward artificial neural network that generates a set of output from a set of input. MLP uses backpropagation for training the network, which is we use MLP in WEKA to train the dataset from the user input the dataset. Next, left bias. Left bias algorithm is a classification technique based on Bayes' theorem with an assumption of independence among predictors. Left bias model is easy to build and particularly useful for very large dataset, which is we use left bias to build a large dataset. Next, decision tree. Decision tree classifier consists of decision tree generated on the basis of instances. Decision tree has two types of nodes, which is the root and the internal nodes and the left node. As example, for decision tree is J48. Okay. J48 decision tree classifier is a simple decision learning algorithm, which is only accept categorical data for building a model. Next, I will explain about expected result. This is a table for performance of the classifier, which is left bias, J48, and multi-layer perceptron. First of all, I will show the result using the WEKA. Okay, first of all, we need to open the WEKA. Next, click the Explorer. Next, open the file. For the dataset, phishing website dataset. Okay. Then we will display the attributes for the phishing website dataset. Next, click the classify and choose the classifier. We choose the left bias and we test option by percentage split. This we conclude 50% only. Next, we click start. Okay. Here we display the output for the left bias. Okay. Which is the correctly classified instances, which is include 5157, incorrectly classified instances 370. The bit time taken to build model is 0.12 second, and the accuracy for this classifier net bias, which is 93.3056, which is same as the expected result for net bias. Next, we can use the next classifier, which is multi-layer perceptron. Click from function and click multi-layer perceptron, and the test option is same 50% and click start. Okay, this is the output for the multi-layer perceptron. It takes a lot of time because we have the large data set. Okay, this is the correctly classified instances, which is 5327. Incorrectly classified instances 200, and the accuracy for the multi-layer perceptron is 96.3814%, and it takes a time taken to build a model, which is about 184 seconds. Next, we can choose classifier for the tree, which is we use J48. Okay, we use the same percentage split, 50%, then click start. Okay, this is the output for the classifier J48, which is correctly classified instances is 5258, incorrectly classified instances 269. Accuracy for the J48 is 95.133%, and the time taken to build the model is 1.1 seconds, which is same as the expected result. Next, we talk about training and simulation error table. Okay. First, for J48, we use output for kappa statistic is 0.9008, mean absolute error is 0.0685, RMXE which is 0.2024, relative absolute error is 13.8843%, root relative square root is 40%, 0.7909. Next, for net bias, which is kappa statistic 0.8634, mean absolute error 0.0883, root mean square root is 0.227, relative absolute error is 17.8851, root relative square root which is 45.74 And as for monthly perceptron, the kappa statistic is 0.9263, mean absolute error is 0.0415, root mean square root error which is 0.1759, relative absolute error is 8.4028%, and root relative square root which is 35.4399%. Okay, next, we compare of evaluation measure by class, which we use the classifier TP rate, FP rate, patient recall, F measure, ROC area, and class for the three classifier. Okay. First, for net bias, the TP rate. Next, for net bias, the TP rate, which is 0.901, FP rate 0.042, precision 0.943, recall 0.901, F measure 0.922, ROC area 0.9x1, and the class is negative. Next, for TP rate 0.958, FP rate 0.0990, precision 0.926, recall 0.958, F measure 0.941, ROC area 0.981, and the class is for positive. Next, for J48, the TP rate is 0.927, FP rate 0.029, precision 0.961, recall 0.927, F measure 0.944, ROC area 0.977, and the class is for negative. Next, for the second, for TP rate, which is 0.971, FP rate 0.073, precision 0.944, recall 0.971, F measure 0.957, ROC area 0.977, and the class is for positive. Next, for multi-layer perceptron, the TP rate is 0.946, FP rate 0.022, precision 0.971, recall 0.946, F measure 0.958, ROC area 0.992, and the class is for negative. Next, for TP rate 0.978, FP rate 0.054, precision 0.959, recall 0.978, F measure 0.968, ROC area 0.992, and the class is for positive. Next, in table 4, we describe about the confirmation metric of the three classifiers, which is net bias, Z38, and MFP. Okay, for net bias confirmation metric, we classify as A and B, which is for A, it conclude 2186 and 131, and for B, we conclude 239 and 2971. Next, for J48, for confirmation metric, A and B is classified, and for A it display 2247, 91, and for B 178 and 3011. Next, for multi-layer perceptron for fission metric, it conclude classified as A and B. For A 2294 and 69, and for B, which is 131 and 3033. Okay, that's all from me. Thank you.